A super habitable planet is one that has a higher possibility of supporting life than our own planet, Earth. And scientists have found many of these planets. It seems quite weird, miraculous, and scary too. Let's see what these new planets have for us. Hey folks, welcome to X Universe, where we discuss space and everything in between. In today's video, we'll see scientists discover planets more habitable than Earth. So, let's begin. Because Earth is the only known inhabited planet and life on it is dependent on liquid water, attempts to find exoplanets that potentially support life are centered on Earth-like worlds. However, other scientists believe that other sorts of planets may have conditions for life that are as excellent as, or even greater than, Earth. Indeed, some scientists suggest that focusing just on Earth-like worlds may be excessively anthropocentric and geocentric, thus blinding us in the prospects of exobiology. It simply means that the conditions we live in are not necessarily important for all forms of life. There can be species which might get energy from kryptonite or even lead, who knows? So we should be open to such prospects. As Dirk Schultz-McCoch says, we are so over-focused on finding a mirror image of Earth that we may overlook a planet that is even more well-suited for life. He is an astrobiologist at Washington State University and the Technical University of Berlin. Schultz-McCoch and his colleagues searched the Kepler Object of Interest exoplanet archive for potentially super-habitable exoplanets, focusing on 4,500 planetary systems that have rocky planets within their stars' habitable zones, where liquid water can persist. The researchers published their findings in the Journal of Astrobiology in 2020. The scientists looked at planetary systems with yellow dwarf stars like our Sun, as well as orange dwarf stars, which are cooler, dimmer, and less massive than our solar. Schultz-McCoch said, "Our Sun is actually not the best kind of star for hosting a planet with lots of life on it. In the Milky Way, orange dwarf stars are almost 50% more numerous than yellow dwarf stars. Unlike our Sun, which has an estimated lifetime of less than 10 billion years, orange dwarfs have lifetimes ranging from 20 to 70 billion years. Because complex life took approximately 3.5 billion years to emerge on Earth, the longer lives of orange dwarf stars may allow planets within their habitable zones more time to develop life and accumulate biodiversity. Because Earth is approximately 4.5 billion years old, the researchers hypothesized that the sweet spot for life would be a planet between 5 billion and 8 billion years old. The size and mass of a planet can also affect how effectively it can support life, according to experts. A larger-than-Earth rocky planet would have a larger livable surface area and a thicker, more stable atmosphere. A planet 1.5 times bigger than mass of Earth would likely retain its interior heat for a longer period of time, helping to keep its core molten and its protective magnetic field active for a longer period of time in which life may begin and evolve. Worlds that are somewhat warmer than Earth by roughly 8 degrees Fahrenheit may be super habitable, as they may have greater tropical zones, which support more species on Earth. Warmer planets, on the other hand, may require more precipitation, as increased heat could lead to deserts expanding. Furthermore, planets with the same surface area as Earth but divided into smaller continents may be more livable. When continents become unusually huge, as Earth's former continent Gondwana did around 500 million years ago, their centers are generally far from oceans, resulting in enormous, inhospitable deserts in their guts. Furthermore, because Earth's shallow waters support more biodiversity than its deep seas, scientists believe that planets with shallower waters could support more life. In total, Schultz-McCoch and colleagues discovered 24 possibly habitable planets. None of these worlds satisfied all of the criteria for super habitable planets set by the researchers, although one did meet at least 2 of them. KOI 5725.01 is a 5.5 billion year old planet with a diameter of 1.8 to 2.4 times that of Earth, orbiting an orange dwarf 2,965 light-years distant. It may have an average surface temperature approximately 4.3 degrees Fahrenheit lower than Earth, but if it has more greenhouse gases to trap heat than Earth, the researchers believe it could be super habitable. KOI 5554.01 was Schultz-McCoch's personal favorite of these 24 potentially habitable worlds. This planet is around 6.5 billion years old, has a diameter of 0.72 to 1.29 times that of Earth, and orbits a yellow dwarf 700 light-years away. Schultz-McCoch said, I really liked the average surface temperature, about 27 degrees Celsius, and it's probably about Earth's size and a little bit older than Earth. Each of these 24 possibly habitable planets is more than 100 light years away from Earth. As a result, they are too far away from NASA's Transiting Exoplanet Survey satellite to collect high-quality photographs from in order to learn more about them. Nonetheless, Skolchmakoch stated that future spacecraft, such as NASA's recently launched James Webb Space Telescope, NASA's Luvor Space Observatory mission proposal, and the European Satellite Agency's Plato Satellite Telescope could shed light on these worlds. Skolchmakoch said, "We caution that while we search for superhabitable planets, that doesn't mean that they necessarily contain life. A planet can be habitable or superhabitable, but uninhabited." However, as scientists discover an increasing number of exoplanets throughout the universe, many new contenders for the ideal Earth 2.0 still emerge. Astronomers, for example, discovered 2 mini-Neptune exoplanets in February 2022, which may be changing into so-called super-Earths as they lose their puffy atmospheres. Another claim was made for Kepler 442b, suggesting it to be Earth's distant twin. The first of these is Kepler 442b, also known as KOI 4742.01. Ravi Kaparapu, an extrasolar planet habitability expert at NASA's Goddard Space Flight Center, says the rating is based on planets that are transiting from our observing perspective, and it is based on whether a planet is rocky or receiving enough starlight or how uncircular a planet is. Based on how much starlight Kepler 442b receives and the other criteria listed above, it turns out that this planet has a higher index than a probable Earth-sized planet near a Sun-like star. Better circumstances for habitability may be a more appropriate way of putting it than more habitable, which is a nebulous term. It makes no mention of whether the planet could be uninhabited. A planet's habitability does not imply that it should be colonized. Previously, exoplanets were only evaluated based on their position in regard to their star and whether or not this was in the Goldilocks or habitable zone. This new index takes into account a broader variety of criteria that indicate habitability. For such a great distance, it's very difficult to gather much information about the conditions on an exoplanet, so habitability estimates have to be drawn from the bare-bones data available. Other factors not measured in the index may make a planet much more habitable, such as a strong magnetic field or a lunar satellite. Because it is difficult to obtain much information about the circumstances on an exoplanet from such an enormous distance, habitability estimations must be generated from the bare-bones data available. Other features not quantified by the index, such as a strong magnetic field or a lunar satellite, may make a planet far more livable. Chris Impey, a professor of astronomy at the University of Arizona, says the hallmarks of a supremely habitable planet would be a super-Earth with more water content than Earth, a nearly circular orbit, and a thicker and so better insulating atmosphere than ours. We have found near clones of Earth, but as this research shows, we could do better than Earth for planet B. But the catch is that it's likely to be 100 light years or more away, and the energy costs of going there, even with small spacecraft, are prohibitive. Far cheaper to take care of planet A. So that was it for today, guys. We hope you enjoyed our content. Like and share the video if you did, and subscribe to X Universe for many more amazing videos. Stay tuned as we'll be back soon with another informative video for your amusement. Till then, keep exploring.